So once again, what I'm doing is I come up with my common difference by doing my 12 divided by 4, which equaled 3, which came from this equation, 18 plus 6, or 18 must equal 6 plus 4 of these common differences. I plug in my information to come up with my first term. I come up with my explicit equation, and now I can plug 10 in for that n. I plug 10 in for that n, and we would have our a sub 10 would equal 30 minus 3, which equals 27. So our correct answer is 27. But don't look at this and go, I just added 3. I added 3 times. It's easier. Yeah, I agree. I agree on this problem. Just adding 3 a few times would be easier than coming up with the equation. But remember, on the test, it might not be that simple. I might ask you to come up with the explicit formula. I might ask for the 100th term. Now I could just plug in 100. 300 minus 3, 297. Way easier than adding 3. What would that be? 93 times. All right, questions on that? Okay, then let's go over homework questions. Yeah, Adrian.
Why was 17 15 needed?
Why was 17 and 15 something? What was that?
Like it said it was arithmetic, geometric, or neither. Why was it needed?
I think my problems are different. 1, 2, 3, 4. Is that on the back page?
15's the last one on the first page.
The last one on the first page. Was that the 1, 4, 9, 16, and 27? Or 25? So why is it neither? Well, if I do... So we have 1, 4, 9, 16, and 25, right? What do you think it is if it's not neither?
Geometric.
You think it's geometric? So remember, to be geometric, I need to multiply by the same number over and over and over to get to each one. Well, to get from 1 to 4, I can multiply by 4. That works. But 4 times 4 is not 9. That would actually get you to your 16. So it would not be geometric because it's not multiplying by the same number. I'm assuming that would be the same problem with the next one.
Yeah.
Or the one before it. Is that good?
Yeah.
Okay. Other questions? Yeah.
21.
21. My numbers are different. Can you tell me what 21 is?
Find the first term of the geometric sequence with the sixth term of 1/81st, and then
The common ratio of 1/3? Okay. So find the first term of a geometric sequence with the sixth term is 1 over 81, and common ratio is 1/3. All right. Well, the nice thing is they gave us one of the terms, and they gave us the common ratio. So if I'm looking at a sub n equals my first term times r to the n minus 1. Well, they were nice enough to tell us that their sixth term equaled 1 over 81. So if I'm looking at my sixth term, that would equal 1 over 81. Well, that would equal a sub 1. It is my third term, and my common ratio is 1 over 3. So as I'm reading this, I'm reading, okay, 1 over 81. That's my third term. That's why my n has to be 3. My common ratio is 1/3, so I got that down. Now we just got to solve this equation. So we have 1 over 81 equals a sub 1. Well, this is 1/3 squared. 1/3 squared would be 1 over 3 squared, which would be 1/9. We would just multiply both sides by 9. That would cancel that out. And then I'll have 9 over 81, which I guess we could just reduce to 1 over 9 equals a sub 1. Oh, wait a minute. It was the sixth term. I'm sorry. I misread it. It is the sixth term is 1 over 81. So this should have been... That should have been 6 minus 1. I'm sorry. I misread it. So the sixth term is that. So I'd make it 6 minus 1, which would be 1/3 to the 5th. Let me type that in real quick. So that'd be 243. This would actually be 1 over 243. We need to multiply both sides by 243, and 243 divided by 81, that does equal 3. So we'd have 3 equals a sub 1 in that case. Okay. I'm sure you had it before, and I just kept going. All right, other questions? I just want to very quickly go over the last one. The last one says find the formula for the nth term of a geometric sequence where a third term equals negative 12 and the sixth term is 96. So we have a third term equaling negative 12. And we have a sixth term equals 96. Well, this one isn't quite as nice as the adding one, where I can just do 12 divided by 3. You actually need a kind of a formula. So what I'm looking at is to get from 3 to 6. I kind of have 3 R values that are being multiplied. In other words, to get from A3, A4, A5, let's get rid of those commas, A6, we start at A3 equals negative 12, and we have to end at 96. So what I'm looking at is we need to multiply by some number R 3 times. So that's going to give me the fact that to get from negative, so if I have to get to 96 and I start with the negative 12, I am multiplying by R 3 times to get there. In other words, I'm doing negative 12, not that, negative 12 times R cubed. Which means we have to divide both sides by negative 12, and we need to take the cube root of both sides. And the reason why I'm bringing this up is some people don't know where their cube root button is on their calculators. So if you're not sure where it is, take out your calculator right now, because I'll tell you where your cube root button is. Most of yours will not have a cube root button. Most of yours will not have a cube root button. So what you need to recognize is on your left-hand side, I forget if it's 3 or 4 buttons down, it's a math button. It says math on it. If you click on that math button, you're going to see you have a cube button there, you have a cube root button there, and you have an X root button there. You're going to need that anytime you want a cube root or a bigger root, like a 4th root, you're going to use that X one. So now when we do our 96 divided by 12 and we take the cube root of that, you should come up with this R equals negative 2. Double check. Do 96 divided by negative 12 and take the cube root. Practice using your calculators. I guarantee you, those of you that know how to use your calculator have easier times on standardized tests than people that don't know how to use your calculator. And when you get up to like calculus level classes, especially not so much here, but when you get to a college level math class, you're going to be dependent on using your calculator a lot. So practice it. Don't just look at answer keys, practice it. This is how you'd get your R value on this one. Does anyone want me to continue? I know no one asked me about this one. I just wanted to make sure you knew where that button was and how to get your R value here. But would anyone like me to continue? Okay, then we'll get into today's notes. Today's notes are special sequences. In fact, the sequence that Adrian brought up on the bell work or the homework, that's actually a special sequence. And it's probably what kind of made you think it's something. Like there's definitely a pattern there and we can recognize it. It's just not geometric or arithmetic. The first one is, what happens when I have alternating numbers between positive and negative on an arithmetic sequence? Now, here's the problem with this alternating negative and positive. It doesn't look arithmetic. Because to get from negative 1 to 2, I would add 3. If I add 3 again, I am not going to get that negative 3. So our first instinct is to go, well, it's not arithmetic, I can't solve this. But let's take a second and look at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is an arithmetic sequence. It is adding 1 over and over and over. So if I could just wipe these negative signs off, I would have an arithmetic sequence. Well, that means we can actually come up with an arithmetic sequence for it. If you make all these positives and it's arithmetic, you can make an arithmetic sequence out of it. You just have to use one of these two. And I'm going to note that you can use a whole bunch of these, but it's better just to use one of these two, and let's talk about how they work and why I picked these particular ones. All right, let's talk about negative 1 to the n. Negative 1 to the n is going to allow you to alternate between positive and negative. So will negative 1 to the n minus 1, but they're going to do it slightly different. So down here it says write the first four terms of a sub n equals negative 1 to the n times n. So let's write the first four terms. So that means we're plugging 1 in, 2 in, 3 in, and 4 in. When I plug 1 in, note this big N just becomes 1. So we're going to have something with 1. Maybe I'll actually put braces around there. So we're going to start with a 1 because of this N. But we've got to replace this N with 1 also. Well, negative 1 to the first power equals negative 1. So this is going to be negative 1 times 1, which is just going to give you a negative 1. When I plug 2 in, this n becomes a 2. So we're going to have a 2. What does the negative 1 do? Well, it would be negative 1 squared. Negative 1 squared equals a positive 1. So that will be a positive 2. When you plug 3 in, negative 1 cubed goes back to a negative 1. It is negative 1 times 3, which equals a negative 3. My fourth term is going to be a positive 4. Now on our next one, if I'm finding my first four values for the next one, when I plug 1 in for the next one, I have 1 minus 1, which equals 0. Well, negative 1 to the 0th is a positive 1. So we're doing positive 1 times 1, which equals a positive 1. When I plug 2 in, 2 minus 1 is 1. Negative 1 to the first is a negative 1. So we have negative 1 times 2 would give me a negative 2. And following suit, we'd have a positive 3, and we would have a negative 4. So now you just pick out the one that matches what was given to you. I was given a negative 1 to start off with. So if I was told to come up with this equation, I would pick the negative 1 to the nth times n to alternate between negative and positive. Now, like I said, you could do negative 1 to the n plus 1. You could do negative 1 to the n plus 2. You just have to check what happens when I plug in 1? Is it positive or negative? And what do I need? I would stick to just these two. Don't alter them too much. Just use negative 1 to the n or negative 1 to the n minus 1. But like I said, you could use n plus 1. That would be the exact same thing here. Because negative 1 to the 1 minus 1 is 0. Negative 1 to the 1 plus 1 would be 2. That would also make it positive to start off with. All right, let's do a couple examples. For starters, I want you to change your b to this. We're going to stick with the same thing. We're just going to put negatives on it. Yeah?
What is, like, negative 1 squared? Like you did an, it was negative 1 at the nth term, and then the second term.
Are we looking here?
Yeah.
How does that become 2?
Yeah.
Because we're plugging 2 in. So negative 1 squared would be a positive 1.
Yeah.
But it'd be times n, and n was 2. So you're plugging a 2 in for both of those. Yeah, no, we're plugging 2 in for both of those. All right, so we're supposed to write an explicit formula for each. And like I said, it doesn't look arithmetic at first. So when you see 40, negative 60, 80, negative 100, what you need to think about is what if I got rid of the negatives? What if I just go 40, 60, 80, and 100? Then we have an arithmetic sequence. We have an arithmetic sequence whose common difference is 20. So because that's an arithmetic sequence of 20, we can write an equation. That equation would be first term plus n minus 1 times our common difference, which we could simplify down to 20n. 20 times negative 1 is negative 20, plus 40 is going to be a positive 20. That is not my sequence. This does not match my sequence yet. I have to tackle this alternating between positive and negative. So that means I need to either use negative 1 to the nth or negative 1 to the n minus 1. So my equation has two possibilities. I'm going to start off with just trying negative 1 to the nth. And we're going to multiply that by that 20n plus 20. So it's way down there. And put the other slide on. All right. Now remember, if I have negative 1 to the nth, that means when I plug in 1 in, negative 1 to the first power would be a negative 1. My first term would have to be negative. My first term is not negative. So that means it can't be negative 1 to the n. I need to do the negative 1 to the n minus 1, or you could do n plus 1. They'll both give you the same result. Once again, I'm going to check my first term. If I plug a 1 in for this n, 1 minus 1 is 0. Negative 1 to the 0th is a positive 1. That means my first term is positive. Yep, that works. So that would be my answer. Now, if, like B is negative 40, 60, negative 80, so the only difference is I switched the negative signs. Now the first one's negative. That means this equation is going to equal a sub n equals, this time we're going to use negative 1 to the nth power. But we can use the exact same formula, which was 20n plus 20. So depending on what's positive, the first one or the second one, depends on which one of these two you use. I also want to note something. When you are writing your arithmetic sequence, when I'm writing my arithmetic sequence for this one, I would use a positive 40 to plug in my first term. Don't use negative 40. Because when we're writing our arithmetic sequence, we're making them all positive, so we'll always use a positive 40. So once again, when you're writing your arithmetic sequence, you'll use the positive 40, not a negative 40. You use the one that you're focusing on with all the positives. The negative one will take care of all the negatives. All right, questions of alternating positive and negative in an arithmetic sequence. All right, this is only for an arithmetic sequence. Arithmetic sequence alternating need that negative 1 to the n or negative 1 to the n minus 1. When we get to a geometric sequence, you don't need to worry about it. I have two methods down here, but I note that this is my preferred one. When you're alternating between negative and positive, if your R value is negative, it will automatically alternate between positive and negative. We don't have the problem with adding and subtracting. So if I have an alternating sequence that uses geometric sequences, don't worry about it. Just treat it as 2, negative 6, 18, negative 54, ... Because if I came up with an R value, I would say, well, that's times a negative 3. Multiply by a negative 3 will get me a positive 18. Multiplying by a negative 3 will get me a negative 54. So that means my R value equals a negative 3. My first term is 2. You have all the information you need to come up with the sequence. Your geometric sequence will be a sub n equals your first term t times your R value to the n minus 1. That was just the formula we memorized for geometric sequences. Method 2. Method 2, don't use method 2. That is the best and easiest way to put it. The only reason why I'm showing you method 2 is because sometimes people get stuck in their head that if it alternates between negative and positive, I have to use that -1 to some power. So this is for you. For if you're not sure when to use that -1 and you accidentally try to apply it to here. So if you try to apply that -1 to the nth power here, you'd go, okay, let's just treat this as a positive. So you'd be like, oh, let's forget it's negative. Let's just use 2, 6, 18, and 54. Now, instead of having an R value of -3, you'd go, oh, these are all just multiply by 3. Well, if I'm multiplying by 3, then my equation, my geometric equation would be first term times my R value to the n minus 1. However, it's alternating between negative and positive, so I'm going to throw that -1 in out front. So I'm going to go, okay, my official one is going to be -1 to the n. Let's see if n works. My first term should be positive. If I plug a 1 in here, -1 to the first is negative. That doesn't work, so this has to be n minus 1. And then I just throw on that 2, 3 to the n minus 1. Both of these will result in the exact same sequence. But one is a lot easier to get to, and that's this one. So when you're studying this section, just worry about the alternating positive and negatives for arithmetic. This is just for those of us that are on the test and all of a sudden we see the positive and negative and we think that we have to use that -1 and we fall down that trap. It still works. It still works. But I'd much prefer you to know that a geometric sequence, you do not have to worry about alternating. The only one you have to worry about is arithmetic. That means you have to add that -1 to the n or -1 to the n minus 1. All right, questions on geometric alternating between positive and negative. Don't use that second method. Don't. Easiest, just don't use it. But if you do, it works. All right, next thing we're going to talk about are fractions. We've already done fractions. But these are going to be those fractions that don't look geometric and don't look arithmetic. In fact, the entire fraction might not be geometric or arithmetic. So on day 1, we might have saw those and listed them as neither. It's not geometric or arithmetic. But what I want to bring up today is, if you have a pattern that's happening in your numerator, and you have a pattern that's happening in our denominator, we can treat them as two separate series. Two completely different systems. So we could treat the top sequence as ACE. We could treat the bottom sequence as BDF. And we can actually come up with equations for our numerator and our equation for our denominator. So we can see our numerator as one sequence, and we can see our denominator as another sequence. So for example, if I have A is 1/2, 1/4, 1/6, 1/8. If I would look for it being arithmetic or geometric, neither one of them would work. However, I am going to note that the top is always 1. So I can just plug 1 in the top. In the denominator, I have this 2, 4, 6, 8. Well, 2, 4, 6, 8 is arithmetic. You are adding 2 over and over and over again. So our top's just going to be 1, but our bottom is going to be an arithmetic sequence where we do our first term plus n minus 1 times our common difference. So our bottom is our arithmetic sequence. Once again, that is your first term plus n minus 1 times 2. So my actual system, once I simplify that, I guess we could simplify it right here. That would just be 2n. 2 times -1 is -2 plus 2 is 0, so that would be 2n plus 0. So our end equation is just 1 in the numerator. The numerator is always 1. In the denominator, we're going to have 2n. If I plug a 1 in, I have 1 over 2. If I plug a 2 in, 2 times 2 is 4, I got 1 over 4. 3, 2 times 3 is 6, 1 over 6. 4n, 2 times 4 is 8, 1 over 8, that is my term. So although at its whole it's not arithmetic, the denominator is arithmetic. So I'll come up with a sequence for the denominator. Our next one, no matter how you try, is not going to be arithmetic or geometric at a whole. At its whole, it will be neither one of those. However, if you split it apart, 1, 2, 3, 4, well, that's just plus 1, plus 1, plus 1. That's an arithmetic sequence whose first term is 1, plus n minus 1 times the common difference of 1. Well, that would just equal n. Well, we could have just did n to begin with. Our first term is 1, second term is 2, third term, it's just n. Our bottom one, however, is not arithmetic. Our bottom one turns out to be geometric, that we are multiplying by 1/2 times 1/2 times 1/2. So just remember your geometric formula is your first term, which is 8, times your common ratio, which in this case is 1/2, raised to the n minus 1. And you don't need to simplify that. So my numerator is just n. My denominator is 8 times 1/2 to the n minus 1. So my entire equation must include my numerator and denominator. Numerator is going to be n. Denominator is going to be 8 times 1/2 to the n minus 1. Bam, I got it. Not arithmetic, not geometric, but if I pull it apart, it becomes arithmetic and geometric at the same time. So we no longer have, just because it's not geometric or arithmetic, doesn't mean you can't get an equation. In fact, our last one uses exponents. Exponents almost feel like it's going to be geometric, but this is not a geometric equation. This is not geometric because if I tried to make it geometric, I'd go, okay, 1 to 4 would be times 4. 4 times 4 is, oh, that doesn't work. It doesn't work. We're not multiplying by 4. So now I want us to think about this. Well, my first term is 1. When I plug 2 in, I need to get out 4. When I plug 3 in, I'm going to get out 9. When I plug 4 in, I'm going to get out 16. First, 1. Second, 2, 4. Third, 9. Fourth, 16. What pattern's happening here? What pattern is happening here? Theo, because I haven't heard you for a week. Yeah. It's just n squared. Everything's just getting squared. This is 1 squared. This is 2 squared. This is 3 squared. This is 4 squared. So if I asked some n term, well, you're just going to go, well, that's just n squared. Whatever number I get, we're squaring it. And so if I need the 100th term, I would just do 100 squared. So although not geometric, is one I expect you to be able to pick out of a lineup. All right, any questions?